I'm Anil Kumar, and let us further explore rational functions domain. And in this particular case, we have two examples, one of them with multiplication and the other one with division operation. We'll find the restrictions for these rational functions. Let's begin with the very first one. You can also pause the video, look into my suggestion. Okay, so there are three factors in the denominator. Let us equate them one by one to 0. First one cannot be 0. It is in the denominator. That means x is not equal to minus 1. The second one is x minus 3. That cannot be 0. That gives us x equals to 3. And the third one is we could take 5 along with it. 5 x minus 6 not equal to 0. That gives us that when you divide by 5 it is 0. And bringing 6 there, so x is not equal to 0. Right? So these are the restrictions. Now we can write down the restrictions, which are from these calculations, right? So we say restrictions are that x is not equal to minus 1, not equal to 3, and not equal to 6, correct? So these are the three restrictions. Now you can do the same thing with the next question. Now let's do it. There's one difference, that is it has division. So when it has division, we have to consider both numerator and denominator of the divisor. The reason is like this. You could write this statement as x minus 2 over 3 times x minus 3 and write it as a product of x minus 1 over 2x. Do you see 2x coming in denominator? So that leads to restrictions on 2x also. So let's find all the restrictions. First one is from the first factor. 3 cannot be 0, but x minus 3 could be 0, right? So that restriction is x should not be equal to 3 plus 3 when you bring it on this side. Here, equating 2x to 0, we get x should not be equal to 0. And the third one is x minus 1 should not be equal to 0, or x should not be equal to 1. So in this case, the restrictions are 3. One is x is not equal to 3, the other one is 0, and the third one is 1. So 3, 1, and 0. So these are all the restrictions for the given expression. So that is how you should be finding them. Thank you and all the best.